So we are now in topic 2, and I want to show you a case study from the Philippines, the Climate Change Resilient Pilot House. Why Philippines? Well, in Mongolia we don't have any edge application yet, and with this one I want to show you how what we have done in the Philippines with edge. So for the design, for the assessment, and for the certification of that building. So let's start. So that presentation will give you the objectives from the project, priorities, areas which we put the main focus on, and then just the design, briefly design, tools and plan from the CCRPH, the building technology, and then I think for you the most three relevant one, climate change resilience of the building, the green building, and of course the cost. So let's start with the objectives. We had the idea as a team to have at this college there to design a house for low income urban dwellers, so not social housing but affordable housing, to improve their living conditions. However, to achieve that, we had actually three priorities. It should be affordable, it should be climate change resilient, and it should be a green building. So what does it mean, particularly for the climate change resilient? It's different than in Mongolia. Safekeeping of occupants during disaster and passive survivability. So survivability is to sustain the life support and conditions in a building during disaster. So we had three challenging priorities, and we had that already, yeah. So affordability, oops, I'm going a bit out of the picture here. Affordability, we have the Philippine National Housing Authority, and which gives a standard for low-cost housing or social housing. Then for green building, we use the EDGE standard to see where we can save energy, water, and embodied energy savings, so material. And for the climate change resiliency, we used another Philippine green building standard, which includes resilience. So it's one of the few green building standards who actually goes also for resilience. So we made our, when we had the design, we made our used EDGE as a tool to assess if we really would save energy, water, and material. And I'm not sure if you can see it. According to our team internal assessment, we could actually save 60% of, or we should, with this design, should save 60% of energy, 34 of water, 41 for the material. So the line is 20 to get an EDGE certificate. So we were actually quite sure that we can do that. So just a brief look at the design and the plan. So the design was a two-story row house for the urban environment, 72 square meters. It should accommodate 4 to 5 people, low-income owners, and it should be self-shelter for during floods and typhoons. So typhoons, just in November, 3 typhoons went over that area where we built actually that building. So typhoon is a common and very often threat in the Philippines. So here just the plan. So front evaluation, rear elevation, and the look through. So here the front, you can see we have a small balcony. On the back we have a rainwater harvester and the toilet underneath. And here you see the staircase. You will see a little bit more on the next slide. Yeah, so that is a section through, even with a picture. So this is the staircase which we had, and this is the living area, and upstairs the 2 bedrooms which you can see there. So building technology. So this is a part which is new to the Philippines and which we used. It looks like a regular row house, but we used a different way of building that. So we had machines. We created our own machines. These are the mold vibrating ones. This is for the one of the mold there, and mold for hollow blocks. So we had 4 different ones. Just the one which you saw. Then this one around for the rim. Then here for the column, and here the regular, not regular, but the hollow blocks with a closed bottom. I have to get a little bit out here of the picture. Good. Are we okay? We are still recording. Good. So for the next is we also fabricated a vibrating table for the beams which we produced. So these are the beams which we did on a vibrating table. Just vibrating a little bit, that the air bubbles going out, it makes the concrete stronger there. So this is how we do actually the second floor. Oops, I just want to show that here. So we're putting this traverse there, and then inside we fill in with hollow blocks. And also these ones are hollow blocks, so sealed hollow blocks. So that was for the slab. And is it affordable? Well, due to our calculation, we figured out that we actually reduced 40% in the HCB slab, reduction of concrete, with the use of the hollow blocks. Normally, it's not used that you use hollow blocks there. Approximately 30% reduction in steelworks, 50% reduction in mortar use for the closed bottom hollow concrete blocks. So as you can see here, they're closed here. We just put a layer of mortar and set the next one on the top, and so it doesn't fill the gaps inside. This gives also us air wall insulation due to the closed hollow concrete blocks. Reduced consumption of wood, as no wooden formwork was actually used during the construction. And we have a modular architectural system, reduced additional formwork and reduction of waste and wastewater on site. Waste and water on site, approximately 30%. Efficient use of resources, which comes later on, which I did not show you yet. PV, rainwater harvester, energy and water efficient appliance operation, which operational cost of the building are reduced, and thereby making its installation affordable in the long run. So even the running costs. This part I did not, that will come on the next pictures. I just put it there that you can see about not only the affordability during construction, but also during running costs. So I think I will stop here and go on the next. You will get another video of them. Before that will, I think, get a little bit too long. So see you in the next video, where we will talk about the climate change resilient pilot house, the resiliency and the green. Thank you for listening.